In this video, we're going to describe and use the change in base formula for logarithms to help us to evaluate logarithms that maybe don't have a really nice, easy to find answer. So up here at the top, we have the change in base formula in general. So essentially what the change of base formula says is if we have a, b, and c that are positive real numbers and b does not equal 1, if we have this logarithm, which we're pretty familiar with, log base something of a. If we have, let's say, for example, we had log base 7 of 17. Okay, something where it's not super easy to calculate what that logarithm actually is. If we have that, what we can do is we can use the change of base formula to rewrite it. Now, we can choose to write it with any base we want. So that's why they say b just can't be 1. You can choose to write this with whichever base you choose. 2, 3, 4, 5, whatever you want. Typically, we rewrite these either with log base 10. So notice how this is just normal log because any log without a number in the subscript is a log of base 10. Or we'll write it with the natural log, which is log base e. And the reason is because these are the two most commonly used logs, and you actually have buttons on your calculator that will allow you to calculate, log base 10 and log base e, because you can see them along the sides of your calculator. You can see the log button and the natural log button. So essentially, we can write it into any base. I suggest the generic log base 10 or the natural log base e. Now, what we can do here is we can rewrite this logarithm. We can take the logarithm of what's on the inside and put it inside of a log of whatever base we choose. So here, this would be log of whatever base we choose of what's in the inside here, which is 17, divided by log of whatever base we choose with the base of 7, which is the base of our current log. So we can rewrite these and then actually use our calculator to help us calculate them, because log, base something of 17 and log base something of 7 are numbers. They represent an actual value. So here, let's rewrite it into this type of log, just to prove to you that it'll work regardless of what you use. So here we have log base 7 of 17. So we're going to rewrite this as log. This is going to be log base 10, remember, because we're not putting the subscript there. So it's going to be log of what's on the inside, which is 17, divided by log of what's in the base, which is 7. So now if you take your calculator and you type log base 17, you can press enter and see what the decimal is if you would like, which you can see here is approximately 1.23. You can also take log of 7, which again is log base 10 of 7, which is approximately 0.84. So that's what those approximately equal. I'm going to plug it in to get the exact answer. So in order to do that, I'm going to plug it in as is. So I'm going to do log 17, close parenthesis, divided by log of 7. And remember, if log doesn't have a base, we're implying it is always 10. So if I divide those out, I end up with 1.46 is approximately what this logarithm would equal. Now, if you don't believe me, type 1.23 divided by 0.84 into your calculator, and that's approximately what you will get. Now, let's try this with the other example to prove to you that you can do this with the natural logs as well. It doesn't matter what base you pick. It just matters that what's inside goes in the numerator and what's in the base of the log originally goes in the denominator, and that they have the same base. So from here, let's rewrite this. So let's say we did natural log of 17 and then over natural log of 7. So we have natural log of 17, which is approximately 2.83, and natural log of 7, which is approximately 1.95. So that's approximately what those are if we use our calculator. Now I'm going to plug them in together because I want to be as exact as possible. So natural log 17, close parenthesis, divided by natural log 7, close parenthesis. And here I get approximately 1.46, which is the exact same thing. So what's really nice about this is you can choose whichever one you like, base 10, base e, and then from there you can actually calculate a value for any logarithm that you might see just by using this change of base formula. So let's try a couple of examples together. This first one here is log base 5 of 6. So I'm going to rewrite this using the change of base formula. Remember, this inside piece goes in the numerator, this bottom piece goes in the denominator. So we have log of 6 over log of 5. Remember, you can use natural log or you can use a log of any base. I'm using log base 10 because that's easy to use on my calculator. And then if I type that expression into my calculator, I find that that logarithm is approximately 1.11. If I look at this next one here, again, remember, this is your numerator, this is your denominator. So remember, you can use logs of any base, so I'm going to use log base 10. So we have log of 12 divided by log of 7. So if I take log 12 divided by log 7, I end up with approximately 1.28. And then this last one here, remember, this goes in the numerator, this goes in the denominator. So we have log of 1/5 divided by a log of 4. So log of 1/5, close parenthesis, divided by a log of 4. And that's approximately negative 1.16. So super easy formula to use and allows us to evaluate any log.